Okay, so in this lesson, we're going to look at uh, and develop a method for finding the side length or angles in non-right triangles. So up until this point, all our triangles had to be right triangles to be able to use the trig functions. And so now we're going to branch out into triangles that are not right triangles. So this is going to open up and make a lot of problems that might have seemed a little bit more challenging before into a lot easier. Okay, so let's take a look at this. This is called the law of sines. So here is a triangle that's not right. And it could be something like this. It could be an obtuse triangle. It doesn't matter what it looks like. And so what we know and what we have seen or could see is that the law of sines has a series of ratios that are equivalent. So the sine of angle A over side A, so the angle and the side opposite that angle, is the same ratio as all the other angle to side ratios. Okay? When we use the law of sines, we only use two of these at a time. So depending on what information was given to you and what information you're looking for would determine which one of these things that you're going to use at any one time. We only do two at a time. We don't do all three at once. Okay? How do I know when to use the law of sines? This is the key. You have to have a complete ratio. If you do not have an angle and the side opposite that angle, no matter where it lands, you have to have an angle and its opposite side. You gotta have those values. If you don't, you cannot use law of sines. Okay, but if you do, then you can. And so there is also a case called the ambiguous case. In this scenario right here, you can get triangles that are where there could be two answers or situations where there's no triangle formed. We are not going to look at those because we are dealing in the real world situation. But just know that there is a case called the ambiguous case for law of sines that is explored in other trigonometry classes. I'm just not going to do it here. All right, so let's look at an example of this. And so we're going to look at the classwork 1A. So I'm going to pull that problem over so we can look at it, and I'll show you how this works. So law of sines. There it is again. And so here we go. And I'm going to show you how I want you to write it all out. So in this problem right here, here's our triangle. I see that I have a complete ratio, an angle and the side opposite that angle. And we're going to solve the triangle. And so remember, solving a triangle means I need to find all the angles and all the side lengths. So in this particular case, you can see clearly that I'm probably going to want to do the angle first because I have two of the angles. And so I just need to find the third one. And we know that all the angles add up to 180 degrees. So angle C, and you can write it as, you just do C, is 180 minus 28 minus 36. And then we work this out to get our answer. So 180 minus 26, I'm sorry, minus 28 minus 36. And I get the angle C is 116 degrees. Please make sure you put in your degree symbol as your final answer. So the angles are now done. I want to find a side length. I want to find, we can find B, or now we can find C. It doesn't matter. We're going to find them anyway. So complete ratio, here's how I do it. So I'm going to write the sine of 28 degrees over 4.5 is the same as, and I'll do B first, the sine of 36 degrees over B. And so you end up with this proportion. And so to solve this, we cross multiply and solve for B. And you can do this in one step by simply remembering that to solve for B is I'm going to multiply the diagonal and then divide by the third number. So multiply the diagonal that has only numbers in it, and then divide by the third number, and then I can write it as B equals 4.5 times the sine of 36 degrees divided by the sine of 28 degrees. And so that is B. Now you can give me an approximation. Please round your approximations to 3 decimal places unless otherwise specified. And so you just type this into your calculator. I usually use the fraction template so that I don't have to use parentheses. Put times in between your number. Put a time symbol right here between this. You probably don't need it, but sometimes the calculator could get finicky. Make sure your calculator is in degree mode. Okay, always check to make sure you're in the proper mode on your calculator, or you will get the wrong answer, even though you were typing things in properly. Okay, always double check. And when you're done with that, and you can get your answer here, and we have 5.634. So when I grade this, I'm going to look for this, the work and the answer, the setup, the actual answer, this is the actual answer, and then the approximate answer. So I'm going to give points for all of those stages. You want to make sure that you have all of them shown and represented. Once you have B done, here's C, and then we want to find side C down here. And so always start with the given information. So even though we found side B, don't use it because it's an approximation. You don't use found information if you don't have to. You only use found information, like rounded off information, if you absolutely need to. And we don't. We just go back to the beginning, set it up with angle A and side A. These are given exact answers. And then the sine of angle C, there it is, 116 degrees over side C, and then we just repeat this process. So C is 4.5 times the sine of 116 divided by the sine of 28. Okay, and then we can go into our calculator and approximate that out. So that, and I end up with 8.615. So there's the three pieces. Here's all the work that I would be looking for and giving points for. So this problem right here was probably worth on a test like 6 to 7 points. Okay, 1, 2, 3, 4, 5, 6, 7. So make sure you show all the work nice and neat in this fashion because this is what I'll be looking for. So that's how we do law of sines. We can also do it when we're looking for angles. I don't have an example of that here, so I'll do one of these in class so you can see how the steps you would do for finding an angle. But let's continue on to the next part of our work here because we're going to learn how to find the area of triangles using trig functions. Okay, so to go back to that, let's talk about how that works. So I'm just going to show it to you so you can see it, and I'll talk as I go along. So here's a triangle, ABC, side lengths written on the outside, and I put the height of the triangle into the picture here because to find the area of a triangle, it is 1/2 the base times the height. That's the formula for the area of a triangle. It doesn't change. We're just going to change the way we look at the base and the height. Because if I don't have the height, I only have the side lengths on the outside edges or things like that, then it's hard to find that. So the base is all this. That is length C. So that's why you see a C in here. And then there's H. H is the height. But once I've drawn this with all the stuff in here in my trig ratios, I see that I have a right triangle sitting right here. Since I have a right triangle, the trig ratios apply. Here's angle A. H is the side opposite. And B would be the hypotenuse of the small triangle. So that is the sine function. And so that's why I wrote it over here as the sine of angle A is the opposite over the hypotenuse. See, H over B. So if I solve for H, I get the height is B times the sine of A. So then replace that for H. And you end up with this formula right here, which is a formula used to find the area of a triangle if you aren't given the height, but you're given other information. So what information would you need to find the area of a triangle using a formula of this type? Even though you see it only as BC and sine of A, okay, the same formula applies from any angle on the triangle based off the information you have. Okay, so you can use the formula in this form, or you have the alternative forms from all the other angles would be 1/2 AB and then the sine of angle C, or the area would be 1/2 AC and the sine of angle B. So how do I know which one to use or how to do this? Well, if you look at it, the formula uses side angle side. The formula has B, C, and the angle between. So side, angle, side. So if you have that scenario, those informations, no matter where those are occurring, you can just put that in the formula as, and that's how I remember it, as the side, the two sides and the angle between. The two sides and the angle between. So that's how I remember those. Let's go look at classwork, question number 2, and we'll work that one out together and show you how easy this is. I do recommend that, oh, that's homework. Where's my classwork page? I do recommend that you draw your picture so you can see the information that you have. I have A, B, and C, so it doesn't matter how you draw it. It doesn't have to be perfect. 130 degrees, okay? So this is angle B, so 130 degrees, okay? Call this A, call that C. So then this side over here would be 67, and this side over here would be 29, because the sides are the opposite the angles. And so side, angle, side, I can write the area of this triangle. It's 1/2 67 times 29 times the sine of 130 degrees. Excuse me. And so you would write that out just like that. And then you can give me the area on your calculator. And again, round it to 3 decimal places. So 0.5 times 67 times 29 times the sine of 130. And I get 744.212. And if there's units involved, then we would do units. I didn't do any units in here, so we can just leave it just like that. But it would be, it's an area, so it would be square units. Okay. And so this is the law of sines, and this is finding the area using the area formula for a triangle, the trig ratio, the trig formula for the area of a triangle. And all of these will be test questions on our next test.